All right. Oh, wait. I think that was the wrong button. There we go. Welcome back, everybody. I'm happy to be back. Sorry about being gone last week. It was a rough week as far as allergies and the weather and everything. So my voice is still a little harsh, but it's coming back. And hopefully I don't sound too stuffed. So, but I'm glad to be back. I'm glad to be working on this again. I'm excited to get back. I've redone a few things, and I'm trying to push this channel into a new direction here. So we'll see how it goes. We'll see if I get any more support or anything, and go from there. But yeah, so basically we're just going to get started working on what we've been working on, and that is this MIDI controller. So a couple points of order. Let me flip over to this new screen that I've been working on. I took away the follower goal, and so our current goal for today, we're going to make a model for the button. But you can see in this section down below, I've added these bounties. And if you can fulfill either of these bounties in a way that I think meets the goal, then you can claim them. And in this case, I'm offering a few Doge coins for each one. And if you fulfill that, I see it and agree with it, I'll ask you to send me an address and I can send you those bounties. So we'll see how this goes. If it works at all or not. The amounts are minuscule right now, and that's because I don't have any money, but so I'm doing what I can, but we'll go from there. And I've just noticed that the capitalization is off on one of these, so I'm gonna have to fix that really quick, because otherwise that's gonna bother me. I apologize too if my voice sounds too weird. Like I said, I've had a rough week with allergies and stuff, so just let me know and I'll do my best to speak clearly. Alright, so that looks good. I'm gonna turn the music back on if I can find it. There we go. And yeah, let's get back to work. Also, if the music is too loud, let me know. I can always turn it down if need be. Alright, so we need to make the button model, which I was going to do. I was opening up. Yeah, I wanted to find the data sheet for it. So I looked online to see if I could just get a model sent to me. And the company that makes this button, I don't know if they support this particular button anymore, and they don't want to send a model unless you're like looking to buy 10,000 or so. So, which we're not, obviously. This is more for commercial stuff. So we're just going to have to make it ourselves from the drawing, which is probably fine. Okay, here we go. I've got the, hopefully it's okay if I show this. I've got the data sheet pulled up here. I'll zoom out some. So this has a very basic drawing of all the critical dimensions. And so what we'll do is try and make something based off that. I ordered a chicken and an egg from Amazon. I will let you know. What does that even mean? If you're trying to make me laugh, I'm just confused. But anyways, so we're just going to try and do a very basic model. Also, one other cool thing. I got the switches in for the sliders. So here's what they look like. They're black with these little white stripe on them. And they just fit right on top of the sliders that we have. So it looks exactly like an audio mixer. It's got a little slide switch on there. So hopefully that'll be cool. I'm glad that they fit. It was hard to tell from Amazon. They didn't have any actual dimensions on it, so didn't know if they were really going to fit on these. I was kind of taking a gamble, but they look good. I guess this is kind of a standardized size or something. So, and I was able to measure the distance, and I didn't write it down, of the height, so that we could get the circuit board at the right height to make the switches just barely hover off of the top of the shell. Thanks, Bit of Me. Glad they are, because I told you I was getting black. I forgot to tell you there's a little white stripe in the middle there, but I think that's okay. These are the only ones I could find that were black on Amazon. There's a lot of gray options. All right, hold on. I'm just measuring this with some calipers real quick. Looks like 0.424 inches from the top of the slider casing to the bottom of the slider. 0.424. I should probably write that down somewhere. All right, but that'll give us something to work off of. Let me do something real quick. I'm just going to write this down. All right, excellent. So that looks good. All right, let's get started on this. This is probably going to be a lot of me just like Googling how exactly to make this model. I don't know that I've ever actually designed an entire model in FreeCAD. I've really just imported stuff and moved them around in an assembly. And I got to figure out what things are important. Our model is not going to look nearly as good as the one that they have here. It's just going to be a very basic thing so that we can figure out exactly how big it is and so on and so forth. But that should be good stuff. So let me know if you have any questions or anything you want to talk about, and I will do my best to answer. Hopefully my stream health is looking good. It is. Windows likes to update every time. Okay. I should probably Google this then. FreeCAD. Okay, creating a simple part. Here's some documentation that looks good. And I'm keeping an eye on the chat so you all can try and make me laugh. But I think I'm gonna fight pretty hard against that, because when I decided to do this Dogecoin giveaway, Dogecoins were worth like 5 cents each, and now they're more than that. So this 10 coin thing went from being like 50 cents to being like $3 or $4, depending on the time of day. So it's actually turned out to be a bit more expensive than I originally thought. But at least I bought them when they were cheap. All right. Let's see, new. I really don't know how this is done. Tracing the sketch. Slightly rough dimensions. All right, so the part design workbench. I guess that sounds right. Here it is. If it'll ever load. There we go. Okay, so you gotta make bodies which are in a part. Interesting. And then everything just gets down to, okay, cool. Good to know. I'm learning now FreeCAD. Okay. Let's create a body. I'm gonna hide everything actually. Oh shoot. New part, make it active. Drop that in there. Yep. Okay. I think that's what I want to do. Origin. Okay, I'm just searching through all this stuff. If you have any questions, one of the other bounties on here is useful advice for FreeCAD because I don't think the learning curve is too bad on this software, but anytime you're learning something new like this, like I am, where I've not done this in a long time, it can be pretty daunting. Okay, new create active. Ah, there it is. Interesting. Okay. So I imagine this will have to be multiple bodies within this part, but we'll figure that out as we go. I guess we need to figure out what we do want to name it. Maybe like switch casing. Or just button. Okay. Yeah, we'll see how this goes. In the model tree. Okay, now we want to trace the sketch, which defines the general shape of the part. In case ours would probably be a circle. Along the y-axis. New sketch. Oh, we got to pick the plane. I think on the XY plane, right? Yep. Okay. And then we need to draw a circle from the origin. And then some amount. Then let's go back here. And what is the diameter? I probably need to change this to millimeters. Because otherwise I'm having a really hard time with it. Is this drawing in millimeters? No, it's in inches. Okay. Looks like it's 12 millimeter diameter. Let's see here. I'm trying to figure out. So I don't understand the notation, but it says the diameter is M12 by P1.0. I'm trying to understand what exactly that means. I'm doing my best not to cough right now. Okay, so that's the thread pitch. So M12, I assume, is the diameter. 12 diameter thread. Okay, so it's 12 millimeters wide. And then let me figure out how to change the units so that I can get this correct. File, probably preferences. Oh, here it is. Yep. Give me a second. Units. Standard. Apply. Okay. Now how do I change the... Alright, now I'm trying to figure out how to actually change the diameter of the circle. Oh, there we go. Just drag it. Why can't I set it? Oh, this is a radius, so it needs to be 6. Right? Yep. How do I change the grid? Oh man, I'm gonna learn so much tonight on just basic FreeCAD usage. That's alright. Yeah, Python control. I think I've noticed that before, just didn't realize it. Grid size, 10 millimeters. Okay, that's fine. That's exactly what I was gonna pick. So that means that I'm doing this probably right. Okay, so we're gonna sketch it, and then next, after you sketch, typically you need to extrude things, but first I want to see, like, there's got to be a way, typically in these two, like, just click on this and set parameters to design it. Excuse me. Okay, reading a little more. Give things... Oh, you can give things constraints. How do I do that? Oh, these are constraints. Selected item. There we go. I want it to be 6 millimeters exactly. Awesome. Okay. So now that won't change size at all. Cool. I can change the value of this one. I can't change the value of this one. But I think that's the origin. I just want to make sure it was correct. Okay. So that part looks good. Let me scroll down. So you really should constrain it in a bunch of different ways to make sure it doesn't ever move. In this case, I only need the one, but unless there's like a position constraint, but I think that's what this is. So I don't think I can grab this and move it, can I? Nope. If I turn that off, can I? Nope. Okay. This just shows them. Okay. Doesn't change that they exist. Yep. All right. That looks good. Now, so sketch becomes green when it is fully constrained. Oh, that makes sense, actually. That's kind of a cool feature. All right, close. All right, so that's created now. Sketch version. The part design is activated again. Yada yada. The combo view switches back to the model tab. If you left your body. That's on your body. Okay, so now we're going to figure out how to extrude it. Yeah, let me say this real quick. Okay. All right, so we're doing. Ooh. Okay. All right, that's interesting. Okay. Click on pad. Ah, here we go. This is what I want. Okay. 30 millimeters. Check the reverse box to reverse the direction of the pad, which is actually what I want to do. I want it to go down. So basically, for reference, I'm starting from this point here, the center line, and I'm working down. So it needs to go down 10 millimeters. That's not too hard to do, though. Okay. So, and that's actually what it's done already. So that's basically the outline of the threads there. Now, like I said, we're not going to get very detail oriented here. Okay, so if I click OK on that, then what else do I need to do? I think that's... Okay, yeah, I think that's it for that. And then I need to go through and make all of the other pieces. Okay, so... you can click on a side. Oh, there we go. And then you can make a sketch on that side. Cool, that's exactly what we want to do. And then I could probably hide that if I need to. So if I hide that, yep. I'm learning a lot here. All right, so we need a square 15.5 by 15.5. So it would be half of that, actually. Okay, and then we're going to need constraints on this. All right. Call that. Oh, we can put the links in here. All right, so that needs to be 15.5. We'll move that out here. And that needs to be 15.5. And then we need to center it. So, whoops, didn't mean to do that. So how do we do that? I guess from here to here? Nope. Two points or line ends. I think this is it. Line and vertex. Whoops. There to there. There we go. Okay. And this needs to be 15.5 divided by 2. By 2. Okay. And then the same thing vertically. So we can do that one again. And that's 7.75. Perfect. And now we notice that our model turns green because everything is locked into place. Cool. So now we can close our sketch view. All right, and then that needs to go up 6.5 millimeters. So we've got that selected. Pad it. And we'll make this 6.5. And say OK. Now, it's not actually that shape. It tapers in a little bit, but the drawing that I'm given here does not actually show the exact angle of the taper or anything. So without a very exact drawing, I can't really do it. All right, the button on top of that is square as well. Right? I think I have him here. Yes, slightly smaller square. And only goes up 3.7 millimeters. I don't think I get a drawing that tells me. Oh, I do. Okay, it's 11. All right, size 11. All right. So click on this face. Here we go. New sketch. And then we're going to hide this pad. Draw a new square. And then this is going to be 11. Oops. This is going to be 11. And then 5.5. And 5.5. Okay, that looks good. We can close our sketch view here. And then we need to pad this. And then this is going to be 3.7 millimeters. See, that looks exactly like a button. I never realized quite how lopsided these things were. Okay. Then tilt to this side. And then we need to go down even farther. Ooh, excuse me. Okay, I'm sorry, we're just looking over everything to make sure I caught it all. All right, let's see. Yep, so you extrude down, and it's 10.5. All right, so on this face, and I'm going to close that out. Am I missing something? Oh, no, okay. Oh, wait, I might be in the wrong spot. No, I don't think so. Hold on. Oh, yeah, no. It's hard to see, but it is in the right spot. Okay. There we go. All right, so we need a circle. And then we need to constrain the circle. Sometimes it makes me select and sometimes it doesn't. It's the oddest thing. Oops. All right. 10.5. So slightly smaller diameter. Okay, and that's green. So we close out this. And then we need to add a pad. Wait. Nope, not right. Hold up. Well, let's see if we can fix it here. So this is from the absolute top of the model, the dimension I'm getting. So it's 34 minus 10 minus 6.5 minus 3.7. Okay. Click OK on that. All right, and then this pad, there should be a sketch in here. I need to edit this. Edit sketch. And then I need to edit this constraint. I forgot that this does it by radius. 0.5 divided by 2. Okay. Okay. Close. There. All right. Perfect. That edited the part correctly. All right. So we're almost there. It's basically our button. Don't know if I have any of them just laying in here. I do. These buttons. So there we go. So yeah, you got the square top and then the rounded centerpiece that goes down into the shell, and it's looking pretty good. And it's looking kind of like what we have here. All right. Not done yet, though. We still need to make the contacts. So the little metal ends here. So let me look back at this thing here and see what's going on and go from there. Okay. Let's do another sketch. It's going to be a really small sketch. Did I have something selected? I didn't mean to if I did. Oh, weird. It's weird that this shows it in different like stages. I don't quite understand what's going on there. All right, well. Select that face. Use sketch. Cool. All right, we could probably get away with doing this on the actual thing without hiding it. Okay. I wonder if I can create multiple shapes in the same sketch or if it'll be mad at me for doing that. We're going to try it. So I need to make a square. And then another square. Okay. And then what is this length going to be? Typically 3 millimeters. Okay. Three as well. All right, and then how thick? 0.5. Okay. We can adjust this so that it's more readable. All right, so that's that part done correctly. Now we need to get them positioned right. So there's typically 5 millimeters between them. Between the centers, actually. So 4.5 between them, so 2.25 from the origin. So we'll work off that number. Oops. 2.25. Okay. And 2.25. All right, awesome. And now I'll try and make this once again a little more readable. Okay. And then same thing. And how high up? How wide are they? 3 millimeters, so 1.5. And here. There we go. And they turn green because they're completely locked in. Okay, so we're done with that. Close the sketch. And then we need to pad it. I'm always clicking pad. I'm assuming that's the thing I need to do. Revolve, I selected sketch. Other profile sections. Profiles, created and added primitive. Pad is selected. I guess it's just the pad. Okay. Hey, cool, it did work. It popped out the way I was hoping it would. All right, how long is that? It doesn't say, actually. Measure them real quick. All right, I'm a little worried now because this is going way faster than I thought it would, so. Roughly 5.25 millimeters. Okay. So 5.25. Okay. There we go. And there is our button. In complete glory. All right, cool. All right, so now we can use this to model out where the button would be on the rest of the model. So let me rename this button 1, or how about play button? And we'll actually copy it a few times, and that'll help us get everything sorted out. So if I turn on the rest of these, I think we'll see that it's in the middle of everything. Not really where we want it to be. So let's turn this origin off. Perfect. All right, we probably need to duplicate it a few times. There we go. Stop button. All right, now we got 4 of them. Okay. So we need to position them, and then we need to start making the holes and slots in the main piece. We'll also position the PCB where it needs to be and go from there. We've positioned it vertically and horizontally, but we need to, or side to side and up and down, but we need to position it vertically, like along the Z-axis. Oh, man. Sorry, allergies make it impossible for me to talk. Okay. Let's see here. What would be the best way to do this? I guess move them off to the side first, right? What's the normal view? I've already forgotten. Actually, let me save this. Yeah, the start view. That's it. Okay. All right, and then we can change the placement of this. Oh, you know what? I probably need to change this back to inches. Because everything else is done that way, so I'm going to have to do the math in that in inches as well. All right, we'll move them out along the X until we get them in the right spot. So 5. 6. Whoops. Click stop button. Click this. Enter. Okay. Yep. Seven. And 8. All right. Turn our views back on. There's our circuit board and our assembly. And we need the top shell here too. Okay. I need to learn how to constrain parts in the assembly. That would be the best way to keep this going. All right, let's look at this and see. Our spacing is going to have to be pretty tight for these buttons. Just looking at this now. They're going to have to be pretty close together because they're sizable. That's okay, though. All right, let's move them up a bit, and then we can settle them down. So, Z, just make it 1. Yep, that'll make it be high enough I can kind of figure out positioning. Okay. All right, let's get these on here. So play button first. And then I probably need to pull up the enclosure model. Or parts, and then because I need to find the drawing of this enclosure again. So I can do the math, figure out where to put these buttons. This will be the 17th time I've downloaded this same drawing. All right. What is our spacing here? 3.04 inches. That's right. Between here and here. So what's the best way to divide that by 4? How's it going, Beth? We're just working on designing this 3D model some more. Got the buttons designed now. All right. We need them to be within this piece here. Shoot. What's that? Let's see. Let's figure out how like wide the button is, because it's 15.5, so 7.75 millimeters from the edge. So, 10-hour day. Yeah, those are not fun. Glad you're home though. 7.75 millimeters to inches is 0.305, so 0.306 inches. So that's how much space we need to leave on either side, and then we can split the rest of that. So 3.040 divided by, or not divided, sorry, 3.040 minus 0.306 minus 0.306 is 2.428. And then, honestly, we need to go a little farther than that, because that leaves only a mil of space on either side against the slot. So I'm measuring this distance from here to here and trying to figure out the spacing there. But the way I'm doing it right now is going to leave like no margin for error, and I really don't want that. 3.040 minus, what should the margin be? Maybe 10 mils? 20 mils, probably 20, because in plastics things can vary a lot. So 0.325 minus 0.325 leaves us with 2.39, which we divide that space by 3, because there's 3 spaces between, and we'll get the distance between each of the switches, which is 0.797 from center to center, which should be enough. It's gonna leave things tight, but it should be enough. So 0.797. Okay. So going off that, so we can divide that by 2 for the first one. If from the center, I don't actually know where the origin point is though. Where's the origin for this? Oh, that's almost perfect actually. It's this corner down here. Oh, that's the board. Sorry, I'm looking at the wrong thing. What is this? Okay, it's centered. I'm trying to figure out where the actual center of this entire thing drawing is. And it looks like it really is just the center here of that. Okay, so we could just subtract this from we could set the y component to negative, whatever half of this is. Is the y is the x. I apologize for doing so much math in my head and like not drawing it out really, but this would be the stop button. 0.399 negative 0. Oops, really? I don't even know how it computes that. Go back. Oh, x. Negative 0.399. Okay, perfect. And then I guess for the y, we need to decide, like, spacing-wise, where it's going. I guess we can just set it up higher for a bit. Set this for 2. maybe a little high. Maybe like 1.8. That's probably better. Okay. Let's change all of these to 1.8 so we get that part right. Okay, let's see. So next is the play button. Actually, we can do this. Let's do the record button next because that's the easy one. 0.399 positive on the X. 399. There it is. Okay, and then the next two are a little harder. Add that, and we get 1.195. Okay. So function button is 1.195. 0.195. Ooh, that looks really close to that edge. It should be fine, but it's like really close to that edge. It'll be fine if we get these holes cut by machines. If I'm cutting them myself, we might need to adjust slightly. But we'll deal with that in a second. Okay, and the play button is negative 1.195. Perfect. Almost perfect, of course. How far down are these sticking right now? Because if this is... Let's see here. Where's the bottom? Nope. There it is. Okay, not too bad. But we're not going to have a lot of room if these... Oh, man, it's going to be really tight. It should be fine, but it's going to be really tight. Let me double check something real quick. .085. Oh no! How did I miss that? I messed something up when checking these measurements. But these buttons might be too big for this case. Oh no. Yeah, there's not enough, well, barely enough space in there kind of thing. Could always trim them slightly. Alright, we'll figure that out. Oh, I think I didn't take into account the contacts when I was measuring the actual distance. Alright, sorry. Stop talking to myself, I know. Okay. So we need to figure out where to put them on the Z-axis to get them basically on this platform here. And it would be best if I could do constraints to do that. Let me see. CAD constraints between parts. All right, let's see here. I don't know if there is a way to do it. Oh, it's only like most people are talking about how you have to download tools to do it or plugins. All right, we may just have to do the math then. Well, shouldn't be too hard actually because we know where the origin points are. All right, how high off the center line? 0.110. Where's the center line? There. This line right here is the, as far as I can tell, is basically the center line, which is exactly where I need it to be. So 0.110. Okay, hold on. Trying to figure this out. Trying to figure out how big the lip is on this thing. Well, how's everybody's day going? How's everybody's Tuesday? Okay. 0.446. I'm trying to do all the math to figure out how big this part is and the thickness of this piece here and everything, so I can figure out how far to drop this piece down for it to be just on the right spot. And yeah, it's a little tricky. All right, looks like the top piece here is technically 0.11 inches thick. And it's measured from the whole thing is measured from the bottom of the slip down here, which I don't think is where the origin is at. I think the origin is up a little bit. Yep. Well, maybe. It's really hard to tell. I don't really want to eyeball this, but I might have to. All right, let's just try one. All right, let me change, let's see, appearance. Well, let me change that. Why not? There it goes. Appearance. And we want it to be black, not too black, a little bit less black. There we go. And we'll close that. Trying to do this so we can have some insight. Okay. And then as far as the positioning on this, right. Oh. Oh, that's really close. 0.39. Five, 6. 0.36 is pretty high, or pretty close to it. I hate to do this kind of like, oh, that looks close enough, but I think in actuality that we're gonna have to go with that. All right, 0.36. So let me do that for all of these. It's your hump day, Friday's off. Oh, that's awesome. It's always good to have a Friday off. Makes everything better. All right, let me color all these buttons the same color. Whoops. Appearance. Oh, it's over here. Off screen. Okay. I think we said 39 on each. Yeah, that was what we picked. You can also pick a material. What if we pick plastic? I don't know if you can like render a really nice image of it or something. All right, let's do that with all of these now. The appearance window keeps showing off way out the side here. Nope, not plaster. Plastic. There we go. Next one. Whoops. There we go. So if I don't pick plastic there, do they appear to have a slightly different look, or they look the same? I want to say they look different, but I think it's just my mind playing tricks on me. All right, let's try this again. All right, last one. There we go. Okay, so that's what the buttons look like there. So now we need to figure out Oh man, where the circuit board needs to be to get the switches the right height off the board. I can do that by looking at 0.424 inches. Okay. So basically, let me turn this off. Oh, it looks awesome when all this stuff is coming into place. You know, actually, I need to turn this back on and see where this stuff's going to end up. Is it sticking into the bottom here? Ooh, yeah. Not good. All right, not sure about that one yet. Didn't take into account the length of the button contacts, but that's a serious problem, actually. We probably need to think through that real quick. Does anyone have any ideas? So basically, where the buttons are, they stick through the bottom of the shell, and we really, really don't want that. I could always, like, chop off a little bit of the contact, because I'm just soldering to them anyway, but I really hate that idea, too. Because it's a part of it that's, like, not just going together. But that's a annoying problem right there. I suppose we could put something around them, like another plate or something. I don't know how good that would look. Maybe that's what we could do, like get a 3D plate or something printed and put around the, like underneath the buttons to, like as a spacer to raise them up slightly. I'm going to leave this problem open-ended for now, assuming that we will find a solution, because I mean, we definitely can. It's just a matter of what kind of solution it is and whether or not it'll look good. But if anyone has any ideas, let me know, because it would be useful. All right. So from here, from this piece right here up, there's 0.424 inches between this face right here and the bottom of the switch that goes on to the slider, or the cap that goes on the slider. And we want to position the bottom of that cap to be as close to the actual physical shell as possible. So, and actually, you know what? I think I may have just measured that from a wrong spot. Let me measure this again. Yeah. 0.376 actually. I measured from the wrong place. Okay. How many of these are you going to build? Just 2. It's not going to be anything crazy. So, I mean, whatever solution we could come up with is could be pretty basic. Although it'd be nice to be able to build more if people wanted them. It's just a matter of, you know. All right. So how to get this part right? Well, actually, if we know that, and we can measure the height of the actual thing, then we can just do a kind of a subtraction also. A different button. Yeah, we could possibly use a different button. It's just it was hard enough to find these, and it's hard enough to find something that'll kind of work in this situation. Plus, I've already bought them. And I don't want to spend more money if I can avoid it. If there's a way around it. Okay, yeah, they're 15 millimeters tall, as expected. Okay. So from that, we can figure out how thick the switch is, and we can figure out how much higher off the board the top of this switch needs to be. So if I do a quick check here, actually, let me get to a different unit. Preferences. All right, we're gonna be back in millimeters again. Man, I wish everybody would just use millimeters. I wouldn't have to mix these units together. Okay, so we'll measure from down here, or right here, to this vertex down here. 8.5 millimeters. Wow, so this might actually be wrong, this drawing. Yeah, it's just a momentary single pull, single throw. You won't be able to post a link in the chat, but if you find a part number, I could search based off that. Try to get something that's very like black and basic looking, like not too flashy. I must have done... That's crazy that I think I did this wrong. To end up with 8.505. It's 15 off the switch. I must have done it from the absolute base. Yeah, I can figure that part out real quick, actually. From there to there. 6.5 to 8.5. Which is 15. Yep, I measured it. When I designed the model, I did it from the wrong place. Because I didn't realize exactly how it was working. Alright, that's okay. You know, I might be able to fix this if I sketch on it. I just need to add 6.5 to it. Okay. Not part of the active body. Alright, I will make it the active one. Normally open. Yes, they are normally open. Oh, it's moved into a new position. Okay, this might actually be harder than I thought. Alright, well, we can still take this into account. I wonder if I can modify this. R3. Extruded. Extruded. We need, this is the one we need to change. Maybe I'll toss a few coins to somebody who finds me a great switch that we can just throw in and it's not too expensive. Okay, I need to adjust this. Let's see. Oh, I need to get rid of this sketch I accidentally made. These measurements. And I accidentally put a sketch somewhere, which I can see right here. Where did that come from? Found it. There we go. Okay. Terrence, if you're looking for a part, just real quick, the spacing on the inside of this model, where is it? Here it is 0.924 inches. So it's going to have to be shorter than that, below, on anything below the case, or below the top of the case. So 0.924. All right. So we're still trying to figure out how to extrude this a little higher, even though this model was imported. I gotta figure out an exact way to do this. I thought I could just sketch on it or something, but I guess not. What if I had a sketch here? All right. It puts it up there where it used to be. Where did that go? Why did it land down here again? Although I guess I could move this up. Oh, can I change the translation? You know what? That might actually be the perfect way to do this, because it'll that'll work, because it actually is the correct thickness. It just needs to be adjusted up by an amount that I've already forgotten. All right, by whatever this thickness is. Why is this highlighted yellow? I still don't know. Oh, we're in part design. Let's go to the start mode. All right, there we go. Here to here. 6.5. So it needs to go up by 6.5. Okay. So let's get rid of that. And then this needs to translate up by 6.5. There we go. Perfect. Okay. Good solution. 3. We need to do it to R2 as well. All right. 5. And then same thing to the last one. To the last slider. There we go. Okay, so now those are tall enough. And I know it looks weird in the picture, but they actually are pretty tall switches. Okay. So now we need to figure out how far through the top of the case they need to stick so that our switches will glide along just above the top of the case. So if I drop this back in, and put the buttons back in too. Okay. And then we're going to have to modify all these parts too, man. All right. So we need the top of this to the top of this to be, well, a certain amount, really. An amount that I do not know. All right, hold on. So what's 15 millimeters to inches? 0.590 minus 0.590551. 90551 minus 0.376 equals 2.14. So 2.15 if you round up. And then we probably need to add like 20 mils just for spacing. So yeah, 235 mils, I guess, is a good number. All right, so 235 mils between the top of this and the top of this. So we need to change our units again. Oops, wrong thing. One of these days, I'm going to figure out how to select parts that only come in one, where all the drawings are done in the same units. But I am not winning that today. Okay. So 235 mils between the top of that and the top of this. What is it right now? It's like 0.454. 54 minus 235. It's 219. So we need the PCB to go down 219 mils. 19 mils. I think I just got to follow. It's been a long time since that happened. Who's following? Connor Musician. Thank you for the follow, dude. How's it going? How's your Tuesday? All right, so 219 mils down. What are we at right now? We're at negative 38 thousandths already. So negative 38 minus 219. Oh, shoot. 0 minus 38 minus 219 equals negative 257. It's going all right. I'm recovering from being sick, so I'm glad to finally be back streaming again. I had to take a week off. Been itching to get this project done. Let's do 57 thousandths. All right, so that puts us at the right spot. So these are basically our slide switches in the right height, and then those buttons. Yeah, so I got to ask you, from your name, Connor Musician, does that yeah, it is tedious. Does it imply that you like that you play music, that you are a musician possibly? The reason I ask is because we're making a sound mixing device, and it would be nice to have an expert on the subject. Because I'm an engineer, but I really don't know much about music equipment. So, oh, cool. Maybe you can, maybe you know a little bit about this stuff then and can catch things or provide some insight, or just enjoy it. I don't care if you just don't want to. I understand wanting to be lazy too, or just enjoy watching. Not lazy. Sorry. Okay, so that part's done. So if we take the top of this off, you can see down inside. We still need to find a switch that's a better height, but I think this gives us the right height for this. What's the interface here? Just like MIDI. Yeah, so 4 buttons, a play, stop, record, and then like a function or tempo button, whatever it can be assigned to, and then 3 sliders for sound. So, or 3 faders. I've already gotten the circuit kind of put together in a test format, and I tried it with Ableton. This is the only free music software I could find, and it just it worked fine. Actually, it worked great. So I was able to set it up and assign the buttons to do different things and all that. So the circuit, the code is working. Now we're designing the physical assembly so that I can order these parts and then actually build it. And then I'm building it for a friend of mine who does a YouTube channel where he composes music. So okay. So what do we need to do next? I guess we need to figure out the spacing between the PCB and these bosses, because that'll tell us what spacer we need to buy. And it's actually a lot closer than I thought it was going to be. That's really surprising. But we need to know what, like, what standoff or no, transport faders. Is that what transport is that what like a play button, stop button is called? I don't understand the lingo totally, but all right. So I need to figure out the spacing there. It's so thin too. We may end up not even using like standoffs or anything, but just like washers. All right, let me have to try and get in here somehow. That's not working. Okay. Okay, cool. Good to know. So I need the spacing between this and that. Engineering Reaper lets you indefinitely evaluate full version of its software. Interesting. Yeah, that was part of it too, is I was just trying to throw something together, because I'm not actually going to write any music. I just wanted to, you know, pull one up and just see that I could assign buttons to do things and things like that, which I reached that point. But that's a good tip. I'll have to look into that. Okay. I need to figure out how to find the distance between 2 planes. I wonder if I can find the feature location. All right, so not the PCB, but this. Oh no, these are all independent bodies, so there's nothing. Right, okay. Yep, that's it. Yeah, it depends on if OBS uses the standard, because I did the standard like MIDI protocol over the USB. So if OBS can detect that, then yeah, I'll absolutely be able to assign these to be like my volume music levels and, you know, start streaming button or something like that. So it'd be cool to see. When all this is done, I'm going to post all of the design files on GitHub so anybody else could see this, make it, or make it better. That would be nice. All right, what is the best way to do this? I'm drawing a blank here. the distance between the top of that and the bottom of this circuit board. Here, hold on. All right, so we know that they're lined up. Let me just Google this. Maybe, I remember looking this up before, and I remember looking this up before, but I could never find an answer. How to measure the distance between two faces. Select any combination of any two elements. Book this command. Measure linear in the entry in the top menu. Okay, that works. So that's just measure distance. I need measure linear. Where is that button? It's going to be in one of these other menus. In the 3D view. It's not, I'm already in the 3D view. Measure linear. Tools. I'm going to get there. I'm going to get there eventually. This is always the boring stuff. Me just Googling, trying to figure out how to do things. Searching stuff. Part measure menu. Is it in the part? Is that a menu or a part? Oh, here we go. Measure linear. Okay. And then for the second selection, let me hide this. Put that back. And then we need to look at the bottom. Okay, that didn't work. Why didn't that work? Whoops. I wonder if it's wanting to make sure I click things on the same part. Yeah, so the big question, I'm sure they've got to have something. It's just a matter of like, man, it won't let me like scroll through the model. That's really annoying. Just keep zooming into it. Oh, interesting. Threw some measurements up here. You know what? I could measure through these two faces and decide the thickness of the board. That could actually work. All right, let's try that one and that one. Nope, it won't let me select different parts. Or it will. I'm just adding a ton of measurements. All right, good to know. So the big concern with those, all those button choices is just really, did they look good? And we were trying to find square ones that were very basic, like black, and all that stuff together just was actually making it pretty hard. So, but if you find a specific one that you think looks pretty good or something, like seriously, post a part number and I will go look into it, or tweet it at me later. That's fine too. Really anywhere. All right. So I've done this measurement here, and I don't know what to do with it now. I don't know how to get rid of it. Nope. Okay. Oh, I can clear all measurements. Okay. With one of these buttons. Toggle 3D, toggle delta, toggle all, clear all. There we go. That's what I wanted. .612 PS 1023A red. All right, I will look it up. Let's see what you got. I'm inferring by the fact that it says red in the name that it's a red button. But maybe it's not. All right, this is really funny. That is the literal exact switch that we have here, but the red version instead of the black one. That's literally the red version of these. So it's obviously because it's the same one, it's still too long. That's really funny though. I totally didn't pick out that that was the part number we had already chosen. If I pull the, here we go. Yep, the buttons here. That's these ones right here. Yeah, the link doesn't tell you the part number. I need to include part numbers in these bills of materials, but... All right, back to this. I was so close to getting this. Measure linear. There. There. The height is just a bit too long. It's not, the height itself is actually fine, but it doesn't tell you the height of the including the contacts, and that actually makes it a bit too much. I'm not sure exactly what it is, but I know it's too much. There we go. What is this measuring to? It's measuring from the top of this part to the top of this part. I guess I could do the math, but that's really annoying if that's how it's doing it. Thanks, dude. Thanks for stopping in, and have a good night. Oh, I will do, man. I will let you know. Thanks for stopping by. All right, let's see. Still don't know the best way to do this. I wonder if it has to do with which part I have selected. Seems to a little bit. I just don't understand what that measurement is doing. All right, well, we're going to have to figure this out somehow. Oh, yeah, it is. And it is in inches. And half of these are done in millimeters and half of them are done in inches. It depends on what company you buy them from. If they're a U.S. company, it's usually in mils. So, yeah, sorry about that. I totally forgot to point that out. Okay, how high is the boss from that? The bosses are 0.25 inches high. All right, I can figure this out. I know I can from doing the math. So let's see here. .446. Oh, they really are making this hard to do. I just realized. So, okay, I haven't been. There's nowhere in the drawing does it tell me how deep this lip is, because it's typically not important. But I'm trying to figure out how thick this stupid thing is. Although I guess I could just look that part up. Because it's evenly. Okay, so. All right, so the full thickness is 1.14. Math on stream, 1.14. So, but the interior thickness is 0.924. But we really only, so we need to figure out half that difference. 924. So that divided by 2 is the thickness of the walls, of the bottom and the top. So we'll store that. All right. So from the bottom of the shell up to the top of the shell, so from the inside of the bottom to the outside of the top, is 0.924 plus that number we just calculated, 1.032. And Terrence, I think you're right. When this ends, it's just going to be me picking out some washers because it's going to be such a small margin. Or actually, you may have just been saying use washers on the buttons to raise them up a little bit. Also an option. Okay. So now that we know that, we need to calculate the recess. How far is it recessed? 0.03. So minus 0.03. That's how far recessed the top plate is. All right, cool. And then minus, okay. Minus 0.25, because that's the height of the boss. Or the standoff. Whatever those are called. I've heard them called both. 0.25. I mean, that's how it goes. You do what you got to do. All right, 0.752 inches from the top of here. Let me close this. Let me hide the PCB. So 0.752 inches from the top of this right here to the top of to this face right here. which is what we're going off of. And then we know that the... bring the PCB back so we can measure from the top of this thing down to get our full thicknesses. So we need to add this distance right here. .235, so plus 0.235 equals 0.987 from the top of this to the top of that standoff. So then we subtract out all of these thicknesses, which should be easy, right? All right, I'm going to change this to the start view so I don't accidentally do anything that I don't want to. Okay. So this height here, .591. We need to do this height here, 0.256. And then one last one, this height here, 0.062, hopefully. Or 64 thousandths, okay. 65. That's the standard PCB thickness typically when you're ordering from like just prototype boards and everything from hobbyist houses. All right. Minus 0.591 minus 0.256 minus 0.065 leaves us with 0.075 inches, or 75 mils thick, from the bottom of that circuit board to the top of that standoff. Gonna have to save that number. Okay, so that's really thin. And I don't know if you could buy a standoff that small. So it probably will be a washer. I'll look on McMaster real quick and see. .75. Yeah, that really is like right at the minimum. Yeah, I think we're going to do washers for that. Problem with washers is that they are technically spec'd to a thickness, but they're really just there as a place, like a cushion against bolts and stuff. So they're designed to be in something that's kind of variable. And they really don't have a good tolerance. Like they can vary a lot on the thickness. But it looks like we can easily buy them in the size that we probably need. All right. We're mostly there. We need to, so next time, I'm probably going to call it here, but next time we need to figure out these buttons if we need new ones, and then we'll need to pick out some washers and go ahead and model those in just to make sure that they land in these spaces correctly. Oh, you know what also we need to do? We need to figure out our standoff issue on the other side. Because we actually might need some standoffs here. Because we need a way for this board to stay like... Obviously, we're not going all the way to the other standoff, so we need a way to hold it up. So we'll need to figure that out next time too. So next time is going to be more tedious modeling and things, but that's okay. We'll get there. All right, good stuff. Well, Well, hopefully you all had fun and enjoyed this. I know I did. It was cool to make some progress on this and learned a lot of new FreeCAD stuff, so hopefully that'll help me next time. And yeah, no bounties claimed tonight. I might add another one in there for that button. But we'll figure it out. So, you all have a good Tuesday night, and I will see you all Thursday. And yeah, that's all I got. All right, see y'all later.